In today's competitive market, identifying high quality leads is very crucial. But how can businesses do this effectively? In today's video, we'll be going through this lead scoring model that I developed using Python. By analyzing user behavior, this model predicts leads that are likely to convert, therefore saving time and resources. So say goodbye to cold calling and hello to a more targeted effort that drives results. Before we get into the video, it's important that we understand what lead scoring is all about. So, lead scoring is a technique used by businesses to rank their potential customers based on their likelihood to convert. So, by analyzing the user data, businesses can now prioritize and focus more on those leads that are likely to convert, which does not only save time but also save them valuable resources. In this part of the video, we'll be having a rundown of the Python script to see how the work was done. So first things first, we imported the necessary package. Note that this is not all the package for this predictive model. This is just the basic necessary package we need to import to kick off the work. Then I put in my file, which is a CSV file in my computer. So I have to run this now. And it's still running. Then the next thing here now is to visualize the data frame. This data we just imported and converted to a data frame. So you can see all the columns present. I use the .head function to show only the first 5 rows of the data, and these are the columns present in this data. Now let's check for a null value. We use the df.isNull.sum to show the sum of null values in the data, and we can see that only subscription status have null values of 7,503. So in the data cleaning process, we will take care of this. However, these variables is not actually needed in training the model. This subscription status is not needed in training the model, so we just drop it, and with that we have taken care of the null value. Now let's have a quick visualization of our data set. Here we have the box plot showing the session deletion by subscription status. So it's just to visualize the data set and see if they are well distributed. So that is it. And for easy analysis, we just have to define our target variable here, and we are using the converted column as our target value because that's what we want to put leads that have actually converted or not. So let's have a quick visualization of the converted column. You can see that in this data set, most of the leads do not convert. So that's why we are building this model, in order not to waste time focusing on this lead that do not convert. So we can actually focus on the small percentage that actually convert. And you can see here, less than about 1,000 of the leads actually convert, compared to, let's say, over 9,000 of the leads to 10,000 of the leads that do not convert, which is a very big margin. Now, relationship between campaign source and converted leads. Because if you check in the data set here, you can see that there are campaign sources where this leads was gotten from. Is it social media, email campaign, direct reach out? So we now have a visualization showing the relationship between campaign source. So let's see. So this one is for converted and those who did not convert in social media. So you can see that across campaign sources, we have on average around the same number of leads that converted, and on average again the number of leads that do not convert. So we can see that across campaign sources they are more evenly distributed. So this is the data set again. Now we have to drop some unnecessary columns we do not need here, like the lead ID. This is the lead ID, the age, we do not need that. The location, we don't need that. We don't want location to be a factor in building this predictive model. So, and age, we don't need them to be a factor in building this model. So we drop this column, we visualize it to be sure that it actually dropped using the df.head command. Now the next thing is to convert categorical variables to dummy variables. So if we look where in this data set we have some categorical variables, so we have to convert them to dummy variables. We have app usage frequency, which is monthly, weekly, daily. So they are all categorical variable. Feature usage, the features these leads have actually tested out in this data set, because these leads have actually tried out, they have actually tried out this app, and now we are trying to convert them to pay users. This analysis is focused on a mobile app used for video editing. So it has a paid subscription and a free plan, and our job here is to convert free users to paid subscribers. That's what we are trying to do here. So let's convert this to dummy variables, and now it's done. You can see done. Let's define and map out our target variables. Why? We're using y, which is the converted, and we map it yes 1 and no 0, because this is what we are going to use for the analysis proper. We have done that, and let's see the columns present now. This analysis. These are the columns we have in the analysis now. So let's go ahead and do the correlation analysis, which will aid us in our feature selection. So this correlation analysis will help us select the right variables for this analysis. Okay. We just use this function to convert them to integer 32 type. And now let's run this. Now this is the regression result of this analysis. Now we can see how well these variables relate to the target variable, which is converted. So that's what we are trying to see, and we can see that subscription status paid has a correlation of 1, which shows that actually they converted. So That's why they have one. Remember, I said we will have to drop this subscription status column so that it doesn't in any way affect our results, because we are trying to predict those that will actually pay, not those that have paid. So based on this correlation data above, we are going to select variables that have at least a correlation of 1%. That's what we are trying to do. We are trying to select among these variables those that have at least a correlation of 1% so that we can actually work with them and see actually how they affect the target variables. That if a change in this actually affects this variable, which is our converted status. In order to do this now, we have to define a threshold, and we say that we are working with correlation of 1%. So we define a threshold of 0.01, which is 1%, and the correlation target we are working with is converted, yes. So that's what we want to do. Then we now select the highly correlated features. If I run this code now, you will see it has a columns of highly correlated features that have the minimum correlation of 1%. So these are the these are the variables we'll be working with. Now final dataset dot drop. We named it now final dataset and not df again. Dot drop subscription status paid, because we don't need it. We want to produce those that will actually, not those that paid for this subscription package. The next thing we did here is to normalize the data using sklearn preprocess import standard scaler. This will really help us. Look at it here. This will ensure that all features have the same scale, which can be important for many machine learning algorithms. So we run that quickly, and now we redefine our target variable just for it to be in line. Now it's time to split this data set into training sets and test sets, and we have to split this data set on a 50-50 base. So we have to encode some categorical variables again. Okay. These are the variables we still have in the analysis. And now let's split them using scikit-learn package library. Let's check the shape. Okay, this is the shape of the S train and Y train, Y test and X test also. Model building proper. So in this model building, we'll be building 3 different models, and after we have to select the best from these ones. So we are building the logistic regression model, and we are also building a random forest model, and also an SGBoost model. That's the models we'll be building in this analysis now. A quick run of our logistic regression models produce these results. You can see that the AOC score is 0.911. This is pretty high. Also, I have to mention that this is a dummy data. This data was generated using the Python Faker library. So it's not actually a data gotten from the mobile app. I can't use a real life data to run this analysis that will be put out in public to the public. So this is a dummy data. That's why we may have a high score. So the random forest model, let's see, random forest classifier. Let's see how it performs. It also has an AOC of 0.911. just like the logistic regression model and the XGB boost has a score of 0.911 also. Sorry, this for random forest. 0.906. So this one is different. The SG boost is different. So we have to perform hyperparameter tuning in order to fully tune this model and be sure that they are highly efficient and not just getting some results that may work or may not work in real life. So we'll tune this model one by one, starting with the logistic regression model. The code is still running. So we can see that after tuning this logistic regression model, which initially had a score of 0.911, we now have a score of 0.942, showing that the efficiency of this model was actually improved. Now let's work on the random forest model. It may take some time. So I'll pause the video here and continue when it's done running. So the code is done running now, and you can see it performs similarly even with the hyperparameter tuning. So if you approximate it, you will still get the 0.91, which is what we got initially. So we'll be tuning the SG boost model now. Let's see how it performs. So this is the result for the SG boost model. It has a score of 0.888. So now let's evaluate these models and find the right one for us. So what we are doing here is we are printing the results from each model, from the logistic regression, SG boost, and random forest. That's what we are doing here, so that we can easily visualize it and see at a glance what we need to do. So for the logistic regression, we can see that it has a precision of 0.97, record of 0.99, and F1 score of 0.98, compared to SG boost, which has a record of 1. Also, if we take a look at the confusion matrix for the FG boost, we can see that the correct predicted negative instance is 534. The incorrect predicted positive instance is just 2, which is very low, lower than all these other models we have here. The false negative, which is the incorrectly predicted as negative, is 14, while the true positive is 50. So in overall, this SG boost performed better. Even though it has a lower RSCAUC score, it still performed better than other models in some regards. So we'll be going with the SG boost model. So what we are doing now is the summary of the results, so that we can actually compare the scores. So model selection. Based on the precision, recall, F1 score, and overall accuracy, XGBoost is slightly better overall due to its higher precision and comparable recall and F1 score for class 1. And class 1 here is the high, class 1 is the high converting leads. So despite a slight lower ROA score, A score compared to the logistic and regression and the random forest, we still have to go ahead and use this model because it performed better in some aspects that are actually more important. So do that, we have selected this model, and now we have to save this model because we want to test it out. So what we'll do is to save this model on my local drive, save this model, and run a list of leads with this model and see actually if they are able to predict effectively leads that will convert. So the first thing first is to save this model as job lab file. Okay. So now let's test the model. Before we test the model, let me show you the data set we'll be using to test this model out. So this is a CSV file of just a little data leads that we are trying to run through these models. We have just 49 leads in this data set, and we are trying to run it through these models. So we have the lead ID, the age of the lead, their location, app usage frequency. Remember I told you in the beginning of this Python rundown that we are focusing this predictive model for a mobile app company used for video editing only. So this mobile app has a free package and a paid package. And the goal now is to predict free users that actually needs to be converted to paid users based on their app usage, how they interact with the app, and some other factors. So we have the session duration on average, how many minutes they spend on the app. We have their open mails, so how many mails we have sent to them that was open, the campaign source, and some other variables here. So what we are going to do now is to load it into this Python script so that we can run it in this new model. We can run it in this our saved model and see if actually it predicts leads that are highly convertible. We are going to do that now. New leads is not defined. Let me correct that. This new lead, that's new. Okay. Okay. Let me quickly take care of this error code. So we are finally taking care of the error code. It took a lot of time, but it's finally done. So we now enter into the step where we have to run this our data set through our saved model to see if it actually predicts users that are likely to convert, and it's supposed to rank them on medium, on high, medium, and low probability to convert. So let's run it and see how it works. And now we can see that it has actually done the work. So for each lead ID, it shows the lead category, which is either is a high level lead, just like here. So now we can see it has done all the work for the 49 leads we have in this data here we used for it. So now that is all you can do now is to save it as a CSV file and forward to the marketing team. Now note that this can be automated and added to the CRM directly, where for each user, for each lead it generates, it can predict the chances of the lead converting and probably send an automated mail to the lead directly without having to go through this process. So as you can see here, the model performed very well in predicting high and low level leads. So we just have to focus on these high level leads and send mails to make sure that they convert and probably offer them some discounts and everything that will entice them to convert quickly. That is it for the Python rundown. Let's take a look at this lead scoring case study. In this case study, there are two companies, Company A and Company B. So Company A makes use of a lead scoring model, while Company B do not make use of any lead scoring model. And we will run down to see how efficient Company A is at using this model compared to Company B. Now, Company A, when they generate this list of leads, they run it through their system and only filter high target leads, which they will be reaching out to. While on the other hand, Company B manually sort through the list of leads they have and filter them based on some criteria they might have defined for themselves. So Company A, on the other hand, will move faster and start reaching out to high target leads, therefore increasing their chances of making a sale. While on the other hand, Company B will be reaching out to all the leads, or at least as they segmented it, be reaching out to them, which takes more time. While Company B is still reaching out to their leads, Company A has started onboarding new customers, newly converted leads. They have started the onboarding process, while on the other hand, Company B is still sending up follow-up mails weeks after they have reached out to see if they can secure a sale. So you can see how this model has helped Company A move faster, saved more resources than Company B. This process can even be fully automized in such a way that when these leads are generated, the system immediately starts sending targeted mails to them. You understand what I mean now? Start sending targeted mails to them, which also will filter. Thank you for watching this video. If you enjoyed this video, please leave a like and let me know in the comment section what you think about this project, how it could be made better, and overall how I can make this project series much better. Thank you so much for watching.